My name is Mr. Otero. I'm the coordinator for S.E.C.M.E here at Terra Environmental Research Institute.
My name is Nicholas Hartog, and I work on the generator project.
So my name is Manas Kotha, and I'm the cadre. I'm just overall the engineer of the group.
My name is Sophia Perez-Clavarino, and I'm in the S.E.C.M.E generator mode.
My name is Kelion Pickering, and what I do in the S.E.C.M.E program is work on the team to build a generator.
What inspired me to do the generator project was seeing how other people would do it. It was a very unique competition, and the things that we would do in it were you wouldn't see in the other competitions. For example, using the electrical current, that's different. You don't really see that in all the other competitions. And why I'm doing it, it's just really fun to build.
The purpose of the generator is to use the movement of water to create electricity. FPL is trying to encourage kids to start getting into engineering and to clean energy sources, so this project is a part of that.
Building a generator, it's a pretty common project. I think it's like a project that gets you into engineering. So it deals with the core factors of engineering, which is electrical and mechanical.
I always told my students the engineering design process fit for every situation you have in life. It doesn't matter what you are doing, you always need to know what the problem that you had, how to get the solution, find solutions that already exist in there, brainstorm with other people, communicate with other people, and create your best own solution for that.
So the first thing we would do, like in our engineering design process, we'd get together, we'd brainstorm, we'd come up with ideas and materials we'd probably need. Then after that, we would pick that one design that looks like really nice, that looks like it has a lot of potential. We'll finally design it, and for us, we used a CAD software called Fusion 360.
So CADing, you first need to have an idea in your mind about how to do it. Like, what do you want to see it in your mind before you want to CAD it. You also want to know what the thing does. If you're just going to CAD it without knowing what it does, it's not going to come out properly. So if you want to make the turbine, you need to know what it looks like, how is it going to function, and what weight it's going to be.
And finally, we put prototypes together and see what would work best.
So there's a lot of different ways. What we're doing is 3D printing most of them, because that's our new focus in this group, to 3D print everything to make it lighter, more functional. But if we can't 3D print it, we just use it as a baseline or blueprint to make it out of wood, plastic.
From past competitions, I've learned how to redo my coils, like we're using a new coil system, we're redoing the base. And especially like this year, like directly from last year, we're now gonna try using gear ratio.
So the purpose of the gears for the generator project is that it makes a 2-to-1 gear ratio. And what a 2-to-1 gear ratio means is that for every one time the big gear turns, the small gear turns twice. And what that means for us with the generator project is for every one time the big turbine turns from the water pushing it down, it twists the magnets twice. So that means we will have double the amount of power we would get than if we just used no gear ratios at all.
Our generator is made up of three main components: our stator, our rotor, and our coils. Our stator consists of inside of it, our rotor, and around it, our coils. Now the purpose of the stator is to hold both of those as stationary as possible. For us, we use wood since it's pretty rigid. Our rotor is what spins, and that has the magnets on it. That's what's creating the magnetic field to create the electricity. Now, the coils is what's collecting that magnetic field to create electrical current.
Personally, I've learned teamwork. I think that's a big focus of S.E.C.M.E, to learn how to talk, how to present, and I think that's what kids can learn. They can learn how to communicate, a good way of communicating. CAD files, that's from personal experience, or measurements, designs, ideas.
Like when kids finally get into like an engineering job in the future, they will have to work well with other people. S.E.C.M.E helps teach me how to do that. Like, for example, I'm working with 3 other people, and together we have learned how to better come up with designs together, like how to compromise on designs. Like, for example, if one person thinks this design is not doing well, and someone else thinks another design is not doing well, we may come together and say, hey, how about we test both of them, see what happens, and then we can get the best of both worlds. So, all in all, just S.E.C.M.E I think it's just really important for team building.